Hey guys, welcome to lesson 6.3 where we discuss normal distribution. So the key idea here is that normal distribution, the probability corresponds to area underneath a curve. So two numbers describe everything. A normal distribution is completely determined by its mean and standard deviation, and the total area underneath the curve is 1. So when we look for the probability that something is between two numbers, those two numbers are A and B on my x-axis, and they block off a certain area, and that area underneath the curve, which would be found using calculus integration, but we're not going to mess with any of that. We're just going to get the actual calculations. So we can either do it backwards, we can do either it forward or backwards, and I'll show you both of those situations. So let's get to an example. We have SAT scores with a mean of 515 and a standard deviation of 100. So how would that look like? So we're going to go to Staplet and normal distribution. So we will have a mean of 515 and a standard deviation of 100. What does that look like? Looks like a curve that's centered at 515, and you can see you can go to the left by 100. Each of those is a standard deviation to the left. You can go to the right by 100. Each of those is a standard deviation to the right. So let's say I want to know what percent of all people have, what percent of all people score between 415 and 615 on the SAT. All right, so that's people that score within one standard deviation of the mean. And we expect that to be roughly 68% from our empirical rule. What percent of people score 715 or higher? So 715 or higher. So now we're not doing between two values. We're just going to go to the right of 715. And you can see that 0.0228. So a little bit more than 2% of all people score 715 or higher on the SAT. We can also go to the left of it. So like what percent of people score less than 500? So to the left of less than 500. So this would be roughly 44% of people score less than 500, assuming that's, assuming those, the 515 and 100 are correct. All right, so we can go to the left, to the right, more than. Now, I can also ask what score would put somebody in the top 10% of all score takers. So now we're going to have to work with a different option. So instead of calculating an area underneath a curve, we're going to calculate a value corresponding to an area. And I want to know what's the boundary that separates the top 10% from the remaining 90%. So I want calculated boundary value for a right tail of 0.1. So top 10% of all people. What is that value? 643. So anyone to the right of 643 would be in the top 10%. Anyone to the left of 643.15. So anyone to the right of 643.15. So 644 or higher would be in the top 10%. Anyone to the left of 643.15, so 643 or lower would be in the bottom 90%. What about someone who is in the, let's say someone in the bottom quartile, so in the bottom 25%. So 0.25 would put someone calculated value. All right, so this area, the blue area over here is the bottom 25%. So anyone to the left of 447.55, so 447 or lower is in the bottom 25%. Anyone to the right of 447.55, so 448 or higher would be in the top 75%. So that's how we navigate these. So here we have the pizza guarantee. Delivery times are approximately normal with a mean of 30 and a standard deviation of 5. So same thing, we would go here. We would change the mean to 30, standard deviation of 5. And let's say, so here's my curve, centered at 30. standard deviation of 5. What percent of all pizza deliveries take more than 40 minutes? So to the right of 40, more than 40 minutes, roughly 2.28%. And what if the pizza place wants to make a guarantee to where they, let's say they give away 1% of all pizzas because they're late. So I want to know what value corresponds to 1% on the right. So if I go to the right tail, make that 1%, 0.01, it would be a time of 41.632 minutes. So they could say, if they wanted to be on the safe side, they could say, if your pizza takes longer than 42 minutes to arrive, which is kind of a weird guarantee, but let's just go with it. If it takes more than 42 minutes to arrive, then it's free. And based on their statistics, they would give away less than 1% of all pizzas to meet their guarantee. All right. So same idea. You can move to the, you can use the normal CDF and inverse normal to move backwards and forwards. Setting a passing cutoff, bottom 20% question. A licensing exam with a mean of 72 and standard deviation of 8 wants 80% of people to pass. So if 80% pass, so this would be pass, bottom 20% fail, and it has a mean of 72 and a standard deviation of 8, what would be the cutoff? So we would make the area on the left 20, we would make the left tail area 0.2, and you would have a score of 65.3. So anyone scoring 65 or less would fail. Anyone scoring 66 or higher would pass. So key term, normal distribution. It's a bell curve described by its mean and standard deviation. Area, that's the key concept. The area underneath a curve is the probability of that outcome. We can use the normal CDF function, inverse normal, to get actual values on the curve. Normal CDF gives you the probabilities. Percentiles, if you have a number, like let's say on the SAT where the mean is 515 and the standard deviation is 100, if somebody scores 443, 90% of the people are to the left of that score, so that score would be in the 90th percentile. And then you've got the empirical rule and kind of the summary of what we went over, and that is lesson 6.3 on normal distribution.